Hello and welcome back to Dozzy's Television Workshop, where today we're going to be looking at repairing this beautiful Commodore 64 bread bin. Let's get into it. Okay, so we've got a beige beauty, a bread bin. I have to say this is more caramel coloured. You can see where it's the colour of the plastic has sort of changed between the top and the bottom half there. If we actually manage to have any sun, I shall probably leave it in the sun to bleach. Looks in quite reasonable condition. You can see some weird effects gone on at plastic at the rear here. That's where the ridges lock in. Really strange. Is that a crack? Could be. Anyway, that's what we've got to work with. We've got a power supply. And we've got 1530. I'm going to put that to one side because I suspect, like the VIC-20 video, this might run into multiple parts. So yeah, anyway, all seems to be in reasonable condition. Bit dusty, bit dirty. The dreaded wedge power supply has non-compliant pins, and we must start with the power supply because, well, they have a bit of a reputation, and the reputation is that the 5-volt rail goes high. Now, all the chips in the C64 are rated to an absolute maximum of 5.5 volts. So if this is exceeding that, you're in trouble. The 5-volt rail is rated to 1.5 amps. You can see that. And it's also got a 9-volt AC at 1 amp. That drives various rails inside the machine. Now, I often see on YouTube videos people measuring the voltage output from, example, a ZX81 transformer, and they say, oh look, this is dangerous, the voltage is high. We need to come and address this problem. Now, the Commodore 64's 5-volt regulator is inside there. This is a regulated 5 volts. It's capable of a maximum of 1.5 amps, but even say you're drawing 1 milliamp, 100 microamps, whatever, it should still be somewhere near 5 volts. Certainly shouldn't be any more than 5.5. Now, the 9 volts winding is rated 9 volts at 1 amp. That means it's just a simple transformer in there. Mains going on one side, 9 volts at 1 amp coming out the other side. So, if you just put your meter across the AC winding, the meter is, drawing next to no current, then that voltage will appear higher. And Sinclair Spectrums, Oric 1s, all those machines that have the external power supply, people put it across, and the Oric 1 power supply, for example, is 9 volts. I think it's at 1.5 amps, can't remember. But people put it across there and they go, oh, it's nearly 15 volts. That's because it's under almost no load. So they say, oh, this is dangerous, we've got to scrap it. No, it's not. The regulator is inside the machine. As long as the regulator is working well. Same with the Spectrum, same with the ZX81. That power supply is unregulated. It's the job of the regulator in the machine that will pull a load on that transformer. Its voltage will fall just because of the way it is, and it goes on. So if we measure the 9 volts AC on here, and we're not drawing an amp, it will be more than 9 volts. What the worry is with this one is the 5 volts. That should always be 5 volts. Now, Commodore 64 power supplies come in quite a few different flavours. This is very common here in the UK, a sort of wedge power supply. And there were 2 different revisions of this, and I'm not quite sure which one I've got here. It'll be interesting. Anyway, so there was also a very common sort of black one that looked like a heatsink but was plastic. So 2 different versions of wedges. There was the black one, and I think they did a beige one with ribs on as well. I don't think I've ever seen one of those, but I'm sure the later C64s had them. Now, there are 2 revisions of these beige wedges, and the black ones I wouldn't trust anymore. In fact, I wouldn't trust any of the original C64 power supplies, to be quite honest, to continue regulating that 5 volts. They do suffer. So there are 2 versions of wedges. The black square one with the heatsink look just bin it out and buy yourself or make yourself another one. Wedges, you've got two chances. The black ones are completely potted, so they've been filled up with a potting compound. You're just never going to repair it. There are two versions of wedges. One is potted and one isn't. And just looking through the slots in here, I think this one might be the version that's not potted, which is good because we can actually get it apart and attempt to repair it, or at least I think I can. It's been a number of years. So yeah, my first Commodore 64 as a child, that had a black wedge power supply that failed actually under warranty, thankfully not damaging the machine, otherwise I'd have been gutted. But well, maybe not, it was under warranty anyway. So yeah, let's try and get this power supply apart. One thing you'll notice is there's no screw holes. These aren't stickers or anything, it is glued together. So the trick is we're going to have to get a bit abusive with it. And even if we end up destroying the case, we've still got a chance to put it in another case perhaps, or maybe 3D print some parts. I could be wrong, of course, this could be the potted version, in which case we're wasting our time and we're going to have to make a new one. I need a bigger screwdriver or prying tool or whatever. Here we go. You can see there's pegs in here. There we are. Just starting to get it apart now. There's probably half the internet screaming at me now. You don't need to do that. You just need to do this and it just pops apart and falls in your lap. If I find that out later, I should be pig sick. Oh, I've got a feeling this one is potted. That's why I can't get that end piece out. I'm not going to trust it anyway, so if I do end up destroying it, I've lost nothing and I've learned something. So I think I'm going to get a pair of pliers in there and actually just bend that down and see what's going on. Yes, it is potted. Blast. Okay. Ooh. However. So what we've got here, let's get the leads. It's the transformer itself that's potted in this stuff here. And you can see here these copper wires coming out. That is the output from the transformer itself. So these two wires here are the 9 volts AC that will be higher off load. Can you see this area has been hot here? It's scorched. That's the 5 volt regulator. And I'm just wondering if we can ease, and we can, you know, ease that up and see what we can do about it. I've just snapped that wire off there. Ah, there's the problem. It comes flooding back now. That there, in amongst that potting. Let me zoom in so you can see that a bit better. You can see this is the potting here for the transformer. So these are the lead outs to the transformer here. That is the regulating transistor in there. And you can see the heatsink is completely immersed in potting compound. The regulator fails, loses regulation, the 5 volt rail goes high, we're in for some misery. So what we need to do is build ourselves a new power supply. This is not going to be reliable. Never ever trust it ever again. I wonder if we could undo the goo. I mean, it'd be a lot of work, wouldn't it? Yeah, it's a possibility, but no, it's just not worth the effort. So what we now need to do is remove that lead, because we shall reuse that, because, you know, it's an original style connector. We'll reuse that, for the outputs from the power supply we're going to make. Right, let's move on to that. Right, a few days have passed. I must apologise, by the way, I've not been very well, so my throat's not good. And also, my tremor's really bad. Trust me, it's more frustrating for me than it is for you to watch. But anyway, I've assembled some parts to make our C64 power supply up. I've got one of my favourite clamshell cases that I get from eBay seller Seymour Items. It happens to be local to me and a very good friend. And yeah, so worth giving him a shout if you want to get any of these. You could always 3D print something, of course, but quite a nice little enclosure. I build a lot of stuff in there. If you're familiar with the channel, you've seen a few other projects that use that. I've 3D printed myself this front panel. We've got two holes there, which are going to take two LEDs, one for 5 volts, one for 9 volts AC, and a place for a switch. So that's that. Got a fuse holder. Got a fuse for that matter. There. We've got a couple of LED bezels to go in the holes. Probably have to enlarge the holes because I'm making them purposefully slightly too small so we can tweak them up. We've got two LEDs. I've got a green one and a yellow one. I thought green for 5 volts, yellow for 12. That'll do. Couple of current limiting resistors for said LEDs. They can go in series with the LEDs when we do that. There's a diode. Doesn't have to be anything special. I just happen to have these, which I think are 1N4001s. Could be. You can use a 1N4148, anything you want. 1N4001, yep. And that's just to stop the reverse current through a yellow LED because we're looking at AC. It'll flicker slightly, but I find that somewhat hypnotic and quite enjoyable to watch. Obviously, I've got a rocker switch. And then we come down to the nuts and bolts of it. I've got this. This is an APV 12-5, and it's a horrible dirty one. I left it out of the box as I was doing some spray painting, and it got lightly coated. They're not normally that horrible colour. But this is designed for a LED light strip, but it's constant voltage, capable of 2 amps, and weighs nothing. It's Meanwell, which is a quality brand really. Don't mind their stuff at all. Yeah, class 2 power supply, 5 volts, 2 amps. Now I did stick it on my Chinese load bank, which turned up very rapidly the other day. I bought one of these. I have an old load bank that I built, but I was going to redesign it so I could do constant power and stuff with it. It's only an op amp and a couple of FETs to dissipate the heat. But this was, I think, about 14 quid delivered. And it turned up remarkably quickly. And yeah, it seems to work okay. And what I did is, obviously our C64, let me just put that back down there and it falls everywhere. Our C64 needs 5 volts at 1.5 amps. This is capable of 2. So what I did was actually scope it up. Just make sure as we increase the load, the voltage was always below 5.5, and the noise was acceptable because this is a switched mode power supply, so it's going to be a little bit noisy. But no, good as gold. So I think that's going to do the job for us. More than enough output current, so I'm happy with that. So there we go. And also for our 9 volts AC, I bought this Vigatronics VTX 1214810-409 encapsulated PCB transformer, 115 by 115, 10 VA, 0 to 9 volts. So this came from Rapid Electronics. In fact, it didn't. Here's a tip. I've often used Rapid for transformers. They're quite good. They're they're sort of UK bit of Conrad these days. They used to be their own company, but obviously they've got bought out at some stage. And here's a tip. This was about 3 quid cheaper buying from Rapid via eBay than it was on Rapid's own website. Rapid, what are you playing at? Surely selling by your own website has to be cheaper than paying eBay seller fees. I don't know. Anyway, there it is. It's got some weight to it, so that's encouraging. I do have a 20 VA transformer in my scrap box, but it wouldn't quite fit in the enclosure. So I thought, for the money, I'm going to spend out and get this. So let's just have a little look at the printing on the top, which is horribly faded, actually. That doesn't look very good, does it? Let me just put the light on. I mean, it's legible, but only just. Right, sort of tilt it into the thing. No, 0 to 9 volts AC, 0 to 9 volts AC. On this side, this is 0, 115, 0, 115. So these two windings I need to put in series. That's got a bent pin on it as well. It's been knocked about in the post, hasn't it? And it arrived DHL as well. There we go. So that is the high voltage side to the main. So I'm going to couple those two centre pins together and these two outer ones. Now, the reason I didn't go for a chassis frame transformer is I don't want to go to the hassle of having to earth, because if I screw that through the box, I need to then earth the tags, which is going to involve a 3-pin lead. This I don't have to, it's encapsulated. So if I make, I'm going to have to get back on the 3D printer, 3D print a bracket that goes around here, straps it down, it'll all be plastic, it'll all be secure, and it won't need an earth. So that makes my life just a little bit easy. We shall fuse it somewhere, we should put the mains lead in. Then we've got the two 9-volt windings. Now these aren't 10 VA a piece, they are 5. And we need 9 volts at an amp, which roughly translated is about 9 watts, which is about, well, it's not, it's exactly 9 watts, but it's roughly 9 VA plus or minus the phase. Don't know what we're doing with the phase, but we've got 10 VA then, but we've got to couple those windings together. So then it's 0909. So 0909. So we have to couple the two 9s together and the two 0s together to get it in phase. So then we've got our whole 10 watts or VA available. So that should be adequate. So let me just straighten that pin a little bit more. And it's going to be 10 minutes on Tinkercad, isn't it, to make a bracket up. So yeah, let's just take some measurements. Does that one start at 0? Yes, it does. Trusty DigiKey ruler. 3 years ago. You get them from PCB manufacturers every now and again. Is this going to be accurate enough? So I need to measure that there, which is going to be 36 millimeters. 36 millimeters up by, let's call it 51. I'm going to write these down. 36 by 51. So I want a tab. I want 36 there. I want 51 across. Come down 36 and another foot. I'll put a hole in the foot so we can drill a hole in the box and nut and bolt it in. So yeah, a few minutes on Tinkercad. Let's get that done. whilst the 3D printer is doing its thing, I'm just going to fettle this front panel so all the bits fit. I think it's quite smart. Good. Okay. I'm starting to get to the grips of this now, so that's the back panel. And I'm going to reuse these original mains lead, now fitted with compliant plug, and the original output lead from our wedge power supply, because there's nothing wrong with it. And also it's got strain relief built in. I've just got to cut notches to secure the strain relief into the new back panel. And much the same as Commodore did, just secure it with a bit of adhesive, but it shouldn't be able to pull out. I just need to cut the relevant size notch, so let me just have a measure there. I think if we went for 9mm there, I'm going to have to come up a little bit because there's a ridge in the back of the unit. So probably 12mm there. Let's just mark that out as best I can on here. Get on the side I don't want to cut, be this side. So we want to come 12, 13mm up. Somewhere like that, and about 9mm across. Going to be one there and one there. Where's the square? I think I might just attempt to cut this with the cutters to get started and then file it to finish. Oops. So that's a mains input side. Let's have a little go at that. I've got suicide cutters for just application so we don't break the decent ones. Not exactly square, is it? Just bend that up out the way temporarily, see how far off the mark we are. This has a flat bottom on it, and that needs to go towards the base. So let's just see. Oh yeah, no. Look at that, pretty much good on the first go. I need to take it in a bit because we have to get over this ridge in the bottom of the box, which is like a couple of mil. But I tell you what, as a first go, that's bob on. Just too wide. Let's go for the grips on the end of my wire strippers for a bit more purchase. We get a clean break there. Oh yeah. I've come into the wrong side. Failure to mirror. Let's just hope the output side is the same sort of strain relief. Ah, thank goodness, which it is. Oh, fancy getting that so wrong. See if that pushes down all the way. It does, it's beautiful. Okay, I'm very happy with that. All for a bit of recycling. See, that other power supply didn't die in vain. So we want exactly the same on this side for our mains input. So where were we? We were 12 up, weren't we? No. 15 up, okay. Oops. Try and get it as square as possible. Does that look about right? Yeah. Right, we've just got to sit tight now and wait for that 3D bracket to finish. Moving on to the mains transformer. As you can see, as I said earlier, it's 0115 volts, 0115 volts. This is our primary. So if you're in that bit of the planet, it's suitable for 50 or 60 hertz, this transformer. So if you're in the States or in Europe and you've only got 115 volts available, you need to put these two windings in parallel. So that's the 0 to the 0 and the 115 to the 115. I don't need to do that. I need to just couple the 115 to the 0. So I've got 0 and 115 plus 115 on the other side, giving me 230 volts. And because I'm in the UK, it's exactly what I want. So that's what I've done here. I've just bent those two pins down there and soldered them together. So when I connect my mains across these two outer terminals here, I'll put my live and my neutral in there. On the secondary side, I've got 0909. Now, if I wanted 18 volts, which I don't, we connect the two center pins together exactly the same. I don't. I want 9 volts, but at a higher current. So I need to put these in parallel. So I've got to couple the two zeros together and the two 9s together. So let's get a bit of wire. Something suitable to carry our 1 amp. This is more than suitable to carry our 1 amp. Blob of blue tack to hold it down. Ugh. I'm just going to tin that up, form it into a bit of a loop if I can. There we go. That'll make the stranded wire now seem quite solid. So let's just form that into a little bit of a loop. And then my plan is to hook it on. Now I'm going to have a bracket going across there, aren't I? So I want to hook it on in this direction, really. Just going to squeeze that up so it stays in place while I solder it. Come up a little bit from the bottom. This is obviously potted, this transformer, so I don't want to melt the potting or attempt to melt the potting. So that's either 0 or 9, I can't remember. Let's have a look. As long as they're in parallel. No, that's a 0. So I need to take that round to this pin here to put on two 9-volt windings in parallel. So I'll just snip that off there. So that's our two 0 lines connected together, and same of course with the two 9 volts, and that will give us the full 10 VA, hopefully enable us to pull 1 amp from it. There we have it. Could have made that one a bit shorter, couldn't I? Never mind, that's fine. So we can take our 9 volts either from the end now, because the two are in parallel, or from the two inside ones, or either end or either end. It doesn't matter because they're in parallel. So that's our mains input sorted and our 9 volts 1 amp output sorted. Okay, there's an interesting article actually on the C64 Wiki that talks about the power supply, and yeah, there's a lot of different types there, and including this part on failure. So here are the relevant voltage situations that can kill your 64 and when it's working normally. Homemade power supply, that's what we're doing, and there's a thing here on the C64 power supply connector which is going to give us the pinouts. We need to reverse engineer the pinouts that we cut off our old power supply so we get this right. And there's a lovely little quote down here. It is recommended to check everything twice, for nothing dies as silently as a microprocessor. Very true, that. Right, so obviously we've got these 4 leads inside our power plug here. One's going to be ground, one's going to be 5 volts, and the other 2 are going to be 9 volts AC. You can get the 9 volts AC round either way, it doesn't make any difference. One thing you'll notice, it's a 7-pin DIN socket on the side of the 64, but in this one I've only got 4 pins populated. You see that? Only 4. So it's going to make it quite easy to pin out. First things first, I think I need to strip a bit of this insulation back off here so I can get my multimeter in. Okay, multimeter. I'm going to have it on continuity. I'm just going to confirm continuity. Bingo. And we'll go through the lead. So, according to the C64 Wiki, and these pins are numbered oddly. So, 1, 2 and 3 are ground. So that is 1, 2 and 3. I appear to have none of those. I haven't cut the lead off something silly, have I? No, it fits. Okay. Am I looking at it the right way up? I am. So according to the C64 Wiki, we've got 1 and 2, which is 7 and 6. Those are our two 9 volts AC. The bottom one, which is pin 2, is apparently ground. And then that must be pin 5, which is 5 volts. Okay, so pin 2 is also ground. So I need a blob of blue tag again. The universal vice. Just to hold that in so I can pin it. Okay, so these two are on 9 volts AC. I suspected they were going to be the shorter leads. Yep. Yeah, that's all good. So, do you reckon Commodore used green for ground, maybe? No, they didn't. Ooh, hang on. Yes, they did. Green for ground. And white for 5 volts. I'm just going to write this down on one of my post-it notes. Who's had the pen? I'll use this one. So brown and yellow are 9 vac, 9 volts AC, and green is ground, and white is plus 5 volts. Now, if you read that wiki, you'll also notice that people say designing your own power supply, it's very important to ensure the 9 volts is galvanically isolated from the 5 volts, otherwise you get currents flowing through it, and you need to know what you're doing about that. Because we're using a mains transformer and a separate power supply for the 5 volts, we are guaranteed to be galvanically isolated. So that's good news. Yeah, still waiting on that 3D printer.
Eventually.
Okay, so my 3D printer's done a little job of making a bracket. There's a bit of movement in there, but that's okay because I can put some double-sided tape on the bottom of the transformer, and then that will tighten down against that, hold it snugly into the bottom of the box. So this is our low voltage side, this is the mains side, so somewhere around there I think we can get a switch. That's good. Fuse holder, I think that can just go down there. Now technically it's supposed to have a cover on it, so if we poke our fingers in there we don't get a belt, but let's not take the lid off with it plugged in, eh? Television sets back in the day, they didn't have covers on for years, and then they had like a little sort of almost like dipped rubber thing that went over the top. Anyway, that's looking nice there. Our little 5 volt switching power supply can sit in there, and wiring for the LEDs etc can be over here. So I think the first thing to do is just put in the soldering iron bit I keep for melting holes in plastic. Don't flame me, you've all done it. At least I keep a special bit for such occasions, and it's this one here. So I'm just gonna get that straight and just mark that up. Want one there, want one there. Yep. Right, okay. There we go. So let's just make an M3 sized hole in there. Nasty. Right, that's that. We want one for the fuse holder. Put it tight against the side there. And we're going to come back to the ones for the power supply in a moment. So we want some M3 fixings and some tape. Box of M3 stuff. In fact, I've got a new box of M3 stuff because I was running short the other week and I got the old box, so I bought a kit off Amazon, cheaper than I could get. I used to buy fixings like in random boxes of, you know, just random M3 fittings. Can't seem to get that anymore. It used to be very good on eBay. And we'll want some double-sided tape like that. That's the thick foam stuff. Right. Excellent. Let's just trim this off. So we want some short fittings to go in there. Perfect. Right, I'm just going to put some tape on the bottom of this transformer. Just see if that gives us enough spacing to want to grip before I stick it down. Yeah, that's gonna pull it in nicely. Excellent. So what I'm just going to do is I'm going to put these two screws up through the bottom. There we go. I'm going to take a year to pull the backing tape off. Look at that. First go. That never happens. Insert the bracket on the top. Oh, it's just a job. Right. Make with some washers. And that isn't going anywhere. That's just the job. Right, so we've got choices here. We could go like that. Like that. What have we got coming in from the front panel? That would be nice, because then we've got a bit of wiring available over here. And these two holes would be on solid plastic rather than that sort of vent there. So I'm just going to abuse the iron again. One about there. Oh. One about there. Should have the fume extractor on, clearly. In fact, let's just do that. Right, let's put our bits and pieces back in. Switch the iron off and the fumex off for a minute. Yeah, it really is super solid now, so our mains is going to go that way. Our low voltage bits coming over here, so that's nice. Let's put the lid on the M3 screws, because I don't think we're going to need any more. And knowing my clumsiness, the chances of those ending up all over the floor are, you know, pretty good. Right, so that's going to there. So maybe couple the neutrals up over here. That live can go straight to the fuse first off. Bit of heat shrink on there. Then live and neutral actually need to go to the switch. We need to switch both poles. Where's the switch panel? There it is. And then the live and the neutral come off the switch, go to our power supply, our 5-volt supply, and our transformer. So we've got double pole insulation, isolation I should say, between the mains and the input of these, and via the fuse as well. Right, let's get on with that. I think we do need something of a cover over the top of the transformer here, just to stop wandering fingers getting electrocuted if they happen to open that up. So what I'm actually going to do there is I think we'll 3D print something again. Right, a little bit of a jump cut, because otherwise this video was going to go on forever, and we're only getting to the power supply part. As you can see, I've 3D printed a little shield. Let's just zoom in, shall we, so you get a bit of a better view. There we are. So I printed a little bit of a shield to stop our pinkies coming into contact with the live bits. The two yellow wires here are feeding the yellow and the brown wire, which we identified connect to the correct pins on our 7-pin DIN for the 9 volts AC. Also, we have also hanging off this, if you look there in parallel, so this, we've got a current limiting resistor for our LED. We've got our diode that I mentioned earlier, the 1M4001, and what that's doing is that's preventing, so when the positive half cycle hits, our LED is being lit, and when our negative half cycle hits, this diode is conducting, so it prevents the diode from getting a reverse voltage, because some of these diodes are a little, LEDs, sorry, are a little bit sensitive to reverse voltage, so let's prevent that from happening. 5 volts comes out of there. That's going onto our white lead for positive, green for negative. The negative is also feeding our LED, and the red positive is feeding a current limiting resistor to our green LED. So I think we're about ready for the smoke test. So yeah, let's do that. I'm going to plug that in. We're going to switch it on. We should see 2 LEDs, and we'll measure the voltages. Well, that's disappointing. We're seeing nothing. Right. Why? I know exactly why that is. I have neglected to put the fuse in. So, yeah. Let's put the fuse back in. Now, other things, you know, I said earlier that there should be a rubber cover or something on that, or plastic cover. And also, these days, that should be an HRC, which stands for high rupture capacity. Now, that's a fuse. Instead of having a glass body, it has a ceramic body filled with sand. Much the same as a plug top fuse does if you're in the UK. I haven't got any. And back in the day, we never used to have any. So I'm going to go with that. We're going to switch on. And there we go. So the green light is indicating 5 volts. And the yellow light is indicating our 9 volts AC. I don't know whether you can see that sort of flickering on the camera, but there's a gentle shimmer to it. Because it's only getting half wave rectified DC, I should say. Right, so let's just check our voltages. I'm going to want a little clip. I've got some kicking about. Here we are. So, how can I measure 5 volts? So this needs, really, I want this below 5.5 volts. So if I go between there and this side, which is current limited. Can you see that? You can't. Let me just shuffle the meter in slightly. There we are. And maybe turn the light off, actually, so we don't get any reflection on it. There we go. So you can read the meter now. So that line there. There we go. We got 5.103 volts. And also we should have 9 volts AC. Move to AC there. And that should occur between that one there and any of... Is that going to grip? Go on, you know you want to. There we are. And that pin there. Now, that looks high, but that's okay, because this this transformer is designed to output 1 amp, a little bit more. So the fact that this has risen slightly, this is an unregulated power supply. So the fact that it's showing 11 volts, By the time we've pulled an amp out of that, that'll be pretty much on the money. So 11 volts AC, I'm not worried about that in the slightest. The only thing I am worried about, and if I just switch this off and turn it up so you can see the LEDs. See, I've switched it off. Whoops, I'll just pop the back panel out. Let's pop that back in. Be fine when the top's on. So you can see the green LED is illuminated. It's gone out now. But when I switch back on, the 9 volts comes up a little bit faster than the 5 volts. Now that would have still occurred in the original power supply, but maybe not as much, because this power supply has got to start up. I don't know whether that is going to give us any problems. I'm hoping not, but there's only one way to find out. And we're going to find out in the next edition of Doz's Television Workshop, because this video has gone on too long. So join me next week when we'll stick this bread bin on the bench and find out what's actually wrong with it. Now we've gone through the palaver of making this power supply up, and I'm also going to discuss another method by which we might be able to keep the original power supply whilst making it safe. Now I just want to mention that before I go. I see these things advertised on eBay and other sites called a C64 saver, and because this is such a common problem with the original power supplies that the 5 volt rail increases and does damage, somebody made a little module you could put in between your 64 that would tell you when the power supply was failing. And how I'm envisaging this working in my mind is that it monitors that voltage rail against a known reference, and then in the event of that known reference being exceeded, it lets you know. This worries me because if that was to occur, it might be too late. However, I think there's another way. We can make an inline module that just sorts that 5 volts out and doesn't, in the event of the failure of the regulator and that voltage creeping up, it keeps it lower. And I think I can do it for next to no money. So join me next time here on Doz's Television Workshop, where we're going to look at that C64 and maybe discuss a C64 saver. Thanks for watching as always, and pop back next week for more fun and games with Commodore 64s. See you there. Cheers now. Bye. Oh dear. Yeah, the end goal of this video, let's do that again. Workshop where today we're going to be looking, no. Will that do? Really not sure. One last time, shall we? That's my stomach grumbling. Jesus. Let's stop there.